Hello, we're back talking about sequencing translations. For those of you who needed to review how to translate using a compass and straight edge, that's what we did up here with all the various colors. And now we're going to actually answer the questions that go along with them. So as I look at this, it says these are the directions: translate and translate. And so how does the size of the angle ABC compare to the size of A prime, B prime, C prime? And as I keep telling you guys, the angle measure is the same. And what that means is if I were to get a compass and I were to look at the angle measure from here and the angle measure from there and even the angle measure from the original, they would be the same. And so we have the measure of angle A, B, C is equal to the measure of the angle A double prime, B double prime, C double prime. How does the length of segment ED compare to the length of segment E double prime, D double prime? Well, let's look. This is approximately 5.25 centimeters. And let's go up here. And we see that the distance is approximately 5.25 centimeters. So we can tell that they are the same. And that was what we could hope for. So the length of ED equals the length of E double prime, D double prime. And the question is, why do you think what you observed in parts D and E were true? Translations are rigid motions. So lengths and angle measures are maintained. That's a huge result, and it's really true with rotations and reflections also. This sentence, translations are rigid motions, so lengths and angle measures are maintained. That's really huge for us. Okay, we're going to go through a couple more examples. Now, what's nice about example number 2 is that it's on a grid. And why is that nice for us? Well, it allows us to actually count boxes instead of having to do the compass and straight edge construction. So here it says move it along vector FG and then translate along vector JK. And what I notice is even though JK is over here way to the right and FG are really, really close, that's not the point of this. The point is the direction and distance. And so if you know your distance formula from physics or from geometry, it's all based on Pythagorean theorem. So as long as I keep this part of the triangle consistent, the distance here will also be the same. So what I look at is that this went up 3 and right 2. And so basically you can move each point that same way. So up 3, right 2, so there's A prime, B up 3 over 2, here's B prime, and C prime up 3 over 2, and there's C prime. So when you have a grid, the translations become much, much easier. Will take way less time. They're easy to see. Same things hold though. This went from A to B, went to the right 2 and up 4, and we can see here the same distance is there. B to C goes down to the right 1, down to the right 1. So you've got your distances maintained, and that becomes really nice. If we look at the other vector moved up 1 and right 3. Now notice how I'm not going back to the original, but I'm going to move everything based on the image because it's like a continuation. And so we went up 1, right 3, there's A prime to double prime. Here's up 1 over 3, here's B prime to B double prime, and up 1 over 3, C prime to C double prime. And as I'm looking at each of these shapes, what I'm going to recognize is that they're identical. The angles are the same, lengths are the same. Number 3 continues this, but we're going to translate the figure. Now, one thing I would notice about this figure is that this point doesn't lie exactly on an intersection of a grid. So that just adds a little bit of difficulty to what we're doing, but not a great deal. So what I notice is that if I follow the directions, translate figure A, B, C, D, E, F along figure GH, GH goes down 2. So I'm going to just move A to A prime, B to B prime, C, it's just a bit off, so C prime, D to D prime, E to E prime, and so on. Again, if I were to connect these, my shape looks almost identical. Maybe small human error that I extended a line a little bit too far, or the bubble that represents the point a little bit big, but otherwise the shape looks identical. Okay. Then I noticed that vector ji is in play, so ji, it looks like I went up 2 and to the right 5 spots, so I'm going to write this down just to remind myself. And so now I'm going to move each one of these up 2 to the right 5. So up 2, 1, 2, 3, 4, 5. So this is where A double prime goes. B up 2 to the right 5. There's B double prime. C double prime will be up 2, so it's not quite there, and then to the right 5. D double prime. E double prime. And F double prime. And so if I connect these, and hopefully you can see the real power of having things based on a grid. It allows for much easier plotting, much easier movement. The grid provides the scale so everything stays consistent and equal. And that's what we want with transformations.